Hey guys, it's Mrs. C. Listen, I wanted to come to you right now with just a little bit of a kind of an intuition video on what actually is slope. You know, there's all kinds of formulas, there's all kinds of ways to calculate slope, and I think what happens a lot of times is we lose sight of what slope actually is, which makes it a little bit harder to understand when we're asked to find it. So what I'm going to do is I'm just going to throw down 2 points right now. And if you notice, I've just kind of like got the right-hand side of a coordinate plane. So really the bulk of the quadrant showing is quadrant 1. And so I've got a point in quadrant 1. Let's call that point A. And I've got a point down here in quadrant, looks like that's quadrant 4, right? I got point B in quadrant 4. And all I want to do is find out what is the slope of a line that maybe, ooh, not that line. What would be the slope of the line that would contain those 2 points? And that's how you would hear the question, worded to you. What is the slope of the line that contains both point A and point B? Meaning, what's the slope of the line that connects the dots? So, yes, there's formulas. Okay, I'm going to show you. We've got the ever popular formula, M stands for slope. We've got, oh gosh, what is it? Y2 minus Y1 over X2 minus X1. That's terrifying to look at. All right, so let's just get rid of that. Then we've got some tricks that people use. Like, for example, I use what we call the arrow method. And if you've seen any of my videos, we take 1 point, put it in this one, put 1 point, put it in that one, combine, do the sign things. Okay, that's exhausting too. Let's get rid of that. The arrow method actually is quite easy. But, there's that. There's all these different, what I'm trying to get at is there's all these different kinds of formulas to try to calculate the slope of a line, when the easiest one for you to know is one that I learned, delta y over delta x. Now, delta y over delta x isn't really a formula, it's a concept, right? Delta is the Greek symbol for that we use to represent change. So if you ever hear delta y, we're talking about the change, the mathematical change in y to its change in x. So to say delta y over delta x is really to just say that complicated formula in a quick, fast way. But it's not a formula. It doesn't really tell you how to do it. But does it? I mean, does it tell you how to do it? I think it might. It said the change, right? So if we were actually going to try to find the change in y, and you had 2 points, right? You have point A and you have point B. What is the ordered pair that would go with A? Can you take a look at that and tell me? You'd go over, what would it be? Our x value appears to be a 3, right? Over 3, and then it goes up 1, 2, 3, 4. Looks like it's about 3, 4. And if we come over here to point B, what does that appear to be? We've got 1, 2, 3, 4, 5, 6, 7. I'm getting a 7, -1. Okay, that's pretty easy, right? You know how to find, you know how to plot points, you know how to identify the value of a given point. So at this place, what would be the change to go from one of your y values to the other y value? Well, let's take a look. I always like to start with the lower point when I'm looking at them. You don't have to, but I don't know, feels like it makes sense to go from the bottom up. But I'll do it both ways to show you it doesn't matter. Here's my y value here and here. So my change, if I started at B, what was my actual change when I wound up at A? So I started out at 1. How much did I change to get up to 4? Well, let's count. I went up 1, 2, 3, 4, 5 units. I went up 5 units. So my change was to go up 5. What's my change in X? So I got my change, or my vertical change, was to go up 5. What's my change in X? Delta y over delta x. Well, my X change goes with these guys. So if I was going from B, right, I went up. That was a positive change. And now I'm going to go left. Now, when you move left on the number line, that's a negative change. So I already know my change in x is a negative change because I'm moving towards the negatives. How many units did you move towards the negatives? Well, you were at 7 and you wound up at 3. You don't even have to count, right? If you're at 7 and you wind up at 3, that's a change of 4. You can count, though. You could go 1, 2, 3, 4, and see that you wind up at 4. But you can also just do the math. Okay, my slope is a positive 5 over a negative 4. That's usually written as a negative 5/4. We put the negative on the outside of the fraction because a positive divided by a negative is negative. That's it. That's how you actually find slope, the change in y over the change in x. Now, I said that it would be the same whether I went from the top point or from the bottom point. I went from the bottom point. So let's just reverse it and see, because, you know, it seems like it wouldn't give you the same answer, right? If you do something differently, you should get a different outcome. You would think. Not necessarily. And this is why. If I started at point A instead, what would be my first change? I said it wouldn't matter. So say we went down. That's my negative change. Now I already knew to go from one point up or down to the other, that is a change of 5, because we had counted it. It was up 5, but this time it's down 5. So in this case, my change in y is actually down 5. But now what's my change in x? I know the number's 4, right? Because I've already done the counting. I'm running towards the positives, so it's a positive change. What's a negative divided by a positive? It's still negative. So the answer would still be a negative 5/4. It doesn't matter how you do it. Let's clear this off and let's try again. Say, let's go back to our little coordinate plane. Let me give you another set of points. Let's do one here, and let's do one right there. So I'm going to try to find I can't. I just can't. It's got to go through the points. Okay, there is so much better. All right, I am trying to find my change in y over my change in x. Change in y over the change in x. So how do I find my slope? I just calculate how much I changed my y values and how much I changed my x values. Let's take a look at what those values are. If we were to identify the ordered pair for A and for B, why don't you go ahead real quick for me and identify those ordered pairs. Okay, I think I got them right. I'm identifying A at point -3, 4 and point B at 10, -2. So what would be my change in my y values? I think the hardest thing to do is to remember that with the slope formula, you actually find the change in your y's first. They're the ones on the top. So if you can remember to do that, you're going to be able to remember everything from that point on. So our y change is going to be from, let's go from B, from a -2 up to a 4. Well, that would be a change in 2 here and a change in 4 here. That would be a total change of 6. So my change in y values is up 6. That's a positive move, okay? And then I'm going to have to go to the left. When I move to the left, that's a negative change. So this way, when I am moving side to side, I'm looking at my x values because I'm trying to find my delta x or my change in x. So to go from 10, that would be 10 on this side, and then 3 more gets me to -3, it's going to be 13. And that's going to be a -13. So my slope is 6 over 13, and that can't be simplified. I think that we have always, you know, at this point in your life, if you're working on this kind of math, you've dealt with absolute value before, right? The absolute value of a -10 is 10. And I think that if there was ever an application to absolute value, it's when you're trying to calculate slope, because you see that this was actually a -3, right? But I wrote a +3 because when I'm trying to find distance, I'm using the absolute value, because I just want to know how many whole units I went over this way. It doesn't matter that these are negative units. I was still 3 units from 0. And that's definition That's the definition of absolute value, distance from zero. And so when you're doing these, you're actually employing the rules of absolute value when you're trying to figure out how far did you move. I moved the absolute value of 10, which is 10, and then I moved the absolute value of -3, which was a positive 3 units. Put them together, you moved a total of 13 units to the left. And the negative now just indicates that you moved to the left. Let's try this one more time. You know, you're thinking to yourself, you know, every time you did this, let's say you did a negative slope. Are you in a bad mood or something? I don't know. I can't tell you for sure. I didn't think I was. But let's do this instead. Let's go ahead and calculate the slope of the line that would put those 2 points together. You don't have to have A and B. You can always call one A and one B, but they don't have to have actual names. You can name them Bob and Fred if you wanted to. What's the change from one to the other? So when we look at this line and we're moving up and over, let's go with my delta. You can't use that tool. Okay, let's go with our delta y over our delta x, our change in y over change in x. Let's just do it without even identifying the ordered pairs. How much do we go up? Well, let's see. It looks like I go up. Where am I at? 1, 2, 3, 4, 5, 6. I'm at -6 here, so I'm going up 6. Right? And then I'm going to go up 3 more. So it looks like I have a positive 9 is my vertical change. So I am going up 9. Hopefully I counted my units correctly. And then I'm going to go over towards the positives. That's another positive change. So I'm going to go over. Looks like I'm going to be going over 1 on this side, right? And then I'm going to be going over 3 on this side. Put those two little values together and you get a total positive 4 change. So you have a 9 over 4. Your slope is 9. M equals 9 over 4. That's how you can do slope without any fancy formulas. The fancy formulas make it easier, okay, to find slope without a graph. If you have a graph in front of you, for heaven's sakes, just look at your positive or your negative change and then do it like I did, change in y over change in x. It's all it ever is. It doesn't have to be complicated. All right, guys, hope this was helpful to you. There is a point at which you'll have to know how to calculate slope without a graph. So at that point, maybe you should take a look at one of my other videos on how to calculate slope. We've got all different methods. I've got a trick method I call the arrow method. I find most people enjoy that method over others. So you let me know. Until then, I'll see you on the flip side.